ENG 201 students. For this lecture video, we are going to cover Module 2.2 entitled Ways of Expressing Concentrations. Now that we have basic understanding of solutions, such as electrolytes and non-electrolytes, along with solubilities, we need to know how to quantify these solutions. In other words, how many ions or soluble molecules are dissolved in water. After this lecture video, you must be able to 1. Calculate solution concentrations using molarity and molality. 2. Define the concentration units of mass percentage, volume percentage, and mass volume percentage. And 3. Perform computations or calculations relating to solutions concentrations and its components volumes and/or masses using these units. In general, concentrations in a solution is defined as the ratio of the amount of solute to the amount of solvent. There are different ways in expressing concentrations depending on the need and the use. First, concentrations may be expressed using percentages. So it may be percentage by volume or by mass. And number 2, if solute is at very low concentrations, for example, amount of pollutants in a particular bodies of water, you can use parts per million or parts per billion. Then, most commonly used in chemistry, concentrations are presented as molar concentrations such as molarity, molality, and normality. The first concentration that we will discuss is mass percentage. Mass percentage is given by the mass of the component divided by the total mass of the solution times 100%. The component being referred in the equation is either the solute or solvent of the solution being required by the problem. Note that the unit of mass percentage is percentage, which means that the units of the mass of the component and the total mass should be consistent or the same so that they would cancel out each other's unit. Volume percentage is similar to mass percentage. It is the ratio of the volume occupied by the component and the total volume of the solution multiplied by 100%. It has a similar formula with the mass percentage, just change the mass from the equation with the volume. Mole fraction, given by symbol X, is given by the ratio of the moles of solute or solvent, whichever is being asked in the problem, and the total moles of the solute and the solvent. Thus, when you are asked for the mole fraction of a solute, it can be calculated as the moles of solute divided by the sum of the moles of solute and the solvent. Note that the total mole fraction of all the components of the solution is equal to 1. For our first sample problem, we are asked to determine the mass percentage of the acetone in the solution, the volume percent of ethyl alcohol, and the mole fraction of acetone in the solution. When 35 ml of acetone given by C3H6O with density of 0.790 grams per ml is added to 50 ml of ethyl alcohol given by C2H6O with density of 0.789 grams per ml. The summary of the givens are shown in the table below. The volumes and densities of each of the components are listed accordingly. We can calculate mass percentage of acetone using the formula mass of acetone divided by the mass of acetone plus mass of ethanol times 100%. So we will be needing the corresponding masses of acetone and ethanol. To find their masses, we can use and manipulate the density formula. Then the mass can be calculated as the product of their densities and volumes. Substituting the given volumes and densities, the mass of acetone is given by 0.790 grams per ml times 35 ml, which is equal to 27.65 grams. And the mass of ethanol is given by 0.789 grams per ml times 50 ml, then you have 39.45 grams. Substituting the calculated values of masses to the formula of the mass percentage, we have mass percent of acetone equals 2.65 grams divided by 27.65 grams plus 39.45 grams times 100%. So therefore, we have a mass percent of acetone equals to 41.21%. To solve for the volume percentage of ethanol, we can use the given formula. Volume percent of ethanol equals volume of ethanol over volume of acetone plus volume of ethanol times 100%. Since the volumes were already given in the problem, we can simply substitute them to the given formula to solve for the volume percent of ethanol. Therefore, the volume percent of ethanol is equal to 50 ml over 35 ml plus 50 ml times 100%, which is equal to 58.82%. For part C, we are asked to solve for the mole fraction of acetone. The formula of the mole fraction of acetone is given by the moles of acetone divided by the sum of the moles of acetone and the moles of ethanol. Therefore, we will be needing the number of moles of acetones and ethanol. Let us recall from Module 1 that the number of moles is equal to the mass divided by the molecular weight. The masses of acetone and ethanol were already calculated in Part A, and the molecular weights is an implied given data considering that the molecular formula for both compounds were given. The molecular weights of acetone and ethanol are given by 58.09 grams per mole and 46.08 grams per mole respectively. Therefore, the moles of acetone and the moles of ethanol is given by this equation. Moles of acetone is equal to 27.65 grams divided by 58.09 grams per mole, and that is equal to 0.476 moles. The moles of ethanol is equal to 39.45 grams divided by 46.08 grams per mole equals to 0.856 moles. Therefore, substituting the values of the number of moles to the formula of mole fraction, the mole fraction of acetone is given by 0.476 moles divided by 0.476 plus 0.856 moles, which is equal to 0.357. If ever that the mole fraction of ethanol is being asked as well, we can simply subtract the mole fraction of acetone from 1. This is because the sum of the mole fractions of all the components should be equal to 1. Therefore, the mole fraction of ethanol will be equal to 1 minus 0.357, which is equal to 0.643. Another way of expressing concentrations of solution is through molarity. Molarity is defined as the number of moles of solute per volume of solution in liters. In a mathematical equation, molarity, given by the symbol capital letter M, is equal to the moles of solute divided by liters of solution. Now take note that the divisor here is the volume in liters of the entire solution, meaning it is the sum of the volumes of the solute and solvent. So when we say that we have a 1 molar of solution, it means that there is 1 mole of solute in every liter of the solution. When we say molarity of a solution, it is the moles of solute per mass of solvent in kilograms. Take note that the divisor is kilograms of the solvent. Common mistake encountered here is having a divisor as kilograms of solution. Always remember that it should be the mass in kilograms of the solvent only. For guided problem 2, we consider naphthalene C10H8, the active ingredient of mothballs. A solution of naphthalene is prepared by mixing 25 grams of naphthalene with 0.750 liters of carbon disulfide, CS2, with a density of 1.260 grams per ml. Assume that the volume of the solution is the same as that of the solvent after the solution is prepared. We are asked to determine the mass percent of naphthalene in the solution and the density, molarity, and molality of the solution. The solute in the solution is the naphthalene, while the solvent is the carbon disulfide. The given values in the problem is listed in the table below, along with the molecular weight of both compounds as implied given. For the first part, to determine the mass percent of naphthalene, we need to know the masses of naphthalene and carbon disulfide to be substituted in the formula for the mass percent of naphthalene. The problem already provided the mass of naphthalene. However, for carbon disulfide, only its volume and density are given. We can calculate the mass of the carbon disulfide by multiplying the volume with its density. Thus, the mass of carbon disulfide is given by 1.263 grams per ml times 0.750 ml, which is equal to 947.25 grams. Now, substituting the mass of both components in the equation, the mass percent of naphthalene is equal to 25 grams divided by 25 plus 947.25 grams times 100%, which is equal to 2.57%. To determine the density of the solution, the density is equal to mass over volume, where the mass here is referred to as the mass of the solution, which is equal to the sum of the masses of solute and solvent, while the volume is the volume of the solution. Therefore, the density of the solution is equal to the mass of naphthalene plus mass of carbon disulfide all over the volume of the solution. Substituting the given values, we have the density equals 25 grams plus 947.25 grams all over 750 ml. That will give us a density value of 1.3 grams per ml. To solve for the molarity of the solution, we need to have the moles of solute and the volume in liters of the solution. The moles of naphthalene is not given in the problem. However, we can solve for that using its given mass and molecular weight. The volume of the solution in liters is given by 0.750 liters. To solve for the moles of naphthalene, we divide its mass by its molecular weight, giving us 25 grams divided by 128.18 grams per mole, which is equal to 0.195 moles. Substituting the calculated moles of naphthalene and the liters of the solution in the equation of molarity, we have molarity equals 0.195 moles divided by 0.750 liters, or that is equal to 0.260 molar. In order for us to determine the molality of the solution, we need to divide the moles of naphthalene as solute with the mass in kilograms of carbon sulfide as the solvent. Since we already know these values from the previous items, we can just plug these values in the formula. Thus, the molality of the solution is given by 0.195 moles divided by 0.94725 kilograms, which is equal to 0.206 molal. Dilution is the process of adding water to a concentrated or stock solution to achieve a lower concentration desired for a particular solution. The idea in dilution is, as you add water into your solution, it does not alter the number of moles of your solute present. It only increases the volume, resulting to lower concentration solution. The basis for the dilution formula will be the moles of the solute present before dilution is equal to the moles of the solute present after dilution. To make a more dilute solution from a concentrated solution, we can use the following formula. M1V1 is equal to M2V2, where M here represents the concentration in terms of the molarity of the solution, and V represents the volume. Note that the left-hand side represents the concentration, which is before the dilution happened, and the right-hand side is for the diluted solution, or after the dilution happened. It is worth to note that multiplying molarity with volume will give you number of moles in our equation, which will return to our basis of our dilution formula that the number of moles that does not change during dilution. Please also note that your units for volume should be the same in both sides of the equation. Guided problem 3. A bottle of concentrated aqueous ammonia is labeled 29.8% ammonia by mass. Density is equal to 0.8960 grams per ml. We are asked to determine the molarity of the ammonia solution, and B, if 300 ml of the commercial ammonia is diluted with water to make 2.5 liters of the solution, what is the new molarity of the diluted solution? Given, for the commercial ammonia, we have a concentration of 29.8 weight% of ammonia and a density of 0.8960 grams per ml. And the calculated molecular weight of the ammonia is equal to 17.04 grams per mole. To solve for molarity, we need to determine the moles of solute and liters of solution. However, these were not given in the problem. The problem just provides with the mass percent and density. So basically, we are asked to convert the concentration from mass percent into molarity. Recall that mass percent of ammonia is equal to the mass of ammonia divided by the mass of the solution times 100%. Since the amount of the solution, whether in terms of volume or mass, is not given, we can assume that the total mass of the solution is 1 kilogram. Thus, it can allow us to solve for the mass of ammonia using the mass percent formula. Solving for the mass of ammonia, it will give us a value of 298 grams ammonia. Solving for the moles of the solute ammonia, we have mass of ammonia at 298 grams divided by its molecular weight 17.04 grams per mole. And it will give us 17.49 moles of ammonia. To determine the volume of the solution, we can calculate this by dividing the mass of the solution, which is assumed at 1 kilogram, by the given density of 0.896 grams per ml. This will give us a volume of 1116.07 ml or 1.12 liters. Finally, solving for the molarity of the solution, plugged in the values of moles of ammonia and liters of the solution, we have 17.49 moles divided by 1.12 liters. That will give us 15.67 molar. To determine the molarity of the diluted solution, we use the dilution formula M1V1 equals M2V2. For the left-hand side, or the concentrated solution, the solute has a M1 value of 15.67 molar and a volume of 300 ml. For the right-hand side, M2 is unknown, but the total volume is 2,500 ml. Plugging all the values in the equation, it will give us a diluted concentration M2 equals 1.88 molar. As your graded assessment for this module, please answer the given self-assessment questions. You may also find a copy of these questions in the lecture handout provided by your instructors. Please submit your answers and solutions for the SAQs in the respective submission links provided by your instructors on or before the set deadlines. If you have questions and clarifications regarding the discussion in this lecture video and the SAQs, you may post it in the discussion board of your Blackboard course site. This ends our lecture video on Module 2.2. Thank you for watching and see you again in our next lecture video.